Hello everyone, I am Somesha Janapati, Assistant Professor of Civil Engineering at Vedang Institute of Technology. As we are continuing our numericals on simply supported beam, here we have one question and we will draw the diagram from it. Let's know that a simply supported beam is here, that span is 10 meter. So first let's draw the beam as it is simply supported. So here the end supports are simply supported. Let's name it A and B. Okay. And a uniformly distributed load of 10 kilonewton per meter over the entire span. So the load is 10 kilonewton per meter over the entire span. Next, it also has 2 point loads of 50 kilonewton and W kilonewton at distance of 3 meter and 6 meter from left hand support. So from left hand support you can see at 3 meter we will have 50 kilonewton of load. Here the distance is 3 meter. Okay. And at 6 meter we will have W kilonewton load. The entire span is 10 meter. Okay. Next, the question asked that if right hand side reaction is 100 kilonewton. So, in case of while we are calculating the simply supported beam and shear force bending moment, we need to first find out the reaction forces. So, here one reaction forces, that is RB, is already given, that is 100 kilonewton. We just need to find out reaction forces RA and the magnitude of W. Okay. So let's find out W and RA. We know that summation of all the vertical forces. Okay. Let's FV is equal to 0. So also we can write RA plus RB minus 50 minus W. Okay. So what we will do this uniformly distributed load? If we just draw the free body diagram of this, okay. Next, we will convert the uniformly distributed load to point load. Here you can see 10 kilonewton per meter is applying over 10 meter. Okay, 10 kilonewton load will be applied for 1 meter. So, here the load total is 10 kilonewton multiplied with 10 meter. That means we are having 100 kilonewton of load. At which place? At the mid span of the beam. Okay. So here the free body diagram is going to be like this. And here we are having W kilonewton. Now we will find out the W value and RA value from this. So here we are having minus 100, that is equals to 0. So we can write RA plus RB. In case of RB we can write 100 is equals to 50 plus W plus 100. RA is equals to 50 plus W. Okay, we have the first equation here. So now if also we know that summation of all the moments is equals to 0. Right? So if we find the moment in case of point A, so this RA will be 0. So let's find out moment, summation of moment. We only just need this equation. Okay, summation of moment at point A. So the equation will be RB into the distance, sorry, 10. RB into 10 is equals to W is at 6 meter. So W into 6 plus 100 into 5 and plus 50 into 3. So we know the RB value here 1000 minus 500 minus 150 is equal to W into 6. So $350 so this W value will be 350 upon 6. $58.33. Here we have the W value that is 58.33. Now if we put this value here, so we can get RA. So RA will be 50 plus 58.33. Here you have the RA value that is 108.33 kilonewton. Okay. Here this question is asked about only the magnitude of W and RA, which we already get here. Okay. If now we have RA, RB and W, so that we can calculate the shear force and bending moment, but the question asked about only W and RA value. So let's go to the next question. Here you can see this is something different question, that it is about overhanging beam. So you can see from this part is overhanging and AB support is here. So the question asks to find out the reaction forces. So we know that first let's go for the free body diagram. Okay, this distance is 2 meter and this overhanging part is 1 meter. You can see the uniformly distributed load is here, overall the span. So this 20 kilonewton load is applying in case of the total distance, multiply with 2 plus 1 3, we are having 60 kilonewton of load at the mid span. So here at 1.5 meter distance, this is your 60 kilonewton of load and this 10 kilonewton of load. Let's find out the reaction forces. reaction forces will be here. Let's name it as RA and here RB. So summation of all the vertical forces is equal to 0. We can write RA plus RB is 60 plus 10. We are having the equation that is RA plus RB is equals to 70. Now, movement, summation of movement at point A. So, we can write that RB multiply with 2 is equals to 60 into 1.5 plus 10 into the total distance 3. So, RB into 2 is equals to 60 multiplied with 1.5, that is 90 plus 30. So here we have the RB value 120 by 2, that is 60. Here RB we are getting 60 kilonewton. Okay. If we just put this RB value here, we are having RA as 70 minus 60, that is 10 kilonewton. So we get the reaction values here. The RA as 10 kilonewton and RB as 60 kilonewton of load. Okay. So we have solved one case, one overhanging simply supported beam, and also calculate the magnitude of one force and the reaction forces. So we will solve lots of numericals in our next classes. Till then, stay tuned. Thank you so much.